Hello, I'm Rashid Ben Moussa, Professor in Industrial Engineering at Qadi University in Marrakesh, Morocco. I'm pleased to present today this paper, which deals with Ecodesign pilot improvement based on TRIZ and ASIT tools. The outline of this presentation is as follows. I present first the general problematic of Ecodesign, which justifies the choice of this subject, as well as the research question we try to answer in this work. I will then present Ecodesign pilot in brief, as well as its limits. I after present the new framework developed to improve Ecodesign pilot and its application to reduction packaging objective. Finally, I will discuss the main conclusions as well as some perspectives to improve and extend this work. Ecodesign is a relevant research topic because of the need of powerful and confirmed systematic methods that can support companies in their efforts to develop green products within acceptable time and costs. Ecodesign pilot developed by ADEM and Vienna University of Technology is one of the tools that seeks this purpose. It proposes measures depending on the nature of the environmental impact of the product. However, the assessment phase of the measures proposed by this tool is both subjective and does not stimulate the development of creative solutions. To overcome this major drawback, this paper seeks to rely on TRIZ and ASIT tools to better assess the proposed measures and develop creative ideas within a new framework for Ecodesign pilot measures assessment. Ecodesign pilot is a web tool that has been proposed as a guide to promote and facilitate the integration of Ecodesign in businesses in any sector of activity. The pilot enables the practitioners to improve an existing product by means of appropriate Ecodesign measures. In order to improve the environmental performance, each product requires specific measures depending on its environmental impact at different stages of its service life. Thus, Ecodesign pilot divides products in 5 types depending on its main environmental impact. Type A, raw material intensive. Type B, manufacture intensive. Type C, transportation intensive. Type D, use intensive. And type E, disposal intensive. Ecodesign classical approach uses checklists and controls to assess the relevance and fulfillment of the assessment question for the measure, as well as the feasibility, cost, and action to carry out for each realization area. This figure shows the list of controls used to estimate the relevance and fulfillment of the assessment question for the measure reduce material input for packaging of the objective and strategy reduction package. This control shows the considered measure. It corresponds to a conceptual solution in the TRIZ sense. This one shows the idea of realization of the measure. It corresponds to a technical solution in the TRIZ sense. This question is called assessment question. These controls assess the relevance and fulfillment of the assessment question. Finally, these controls assess the feasibility, cost, and action to carry out for the realization idea. The classical approach of Ecodesign pilot measures assessment is as follows. Rate the relevance of the assessment question with a view to product. 10, very important for product. 5, less important for product. 0, not relevant for product. Estimate then the fulfillment of the assessment question using one of the 4 possible answers. Yes, rather no, or no. The additional questions support understanding of the assessment question and need not to be answered. Select then Ecodesign tasks with high priority and continue only with these. Find ideas to realize the Ecodesign tasks. The content of the learning part with its example shall assist in doing that. Evaluate the feasibility of the suggested ideas, difficult or easy. Compare then the costs of the new ideas with a reference situation, higher, same, or lower, and give a reason for that. Decide finally when to carry out the eco-design tasks and determine the person or department that shall be in charge or further steps in the realization of the product improvement and fix a deadline. This approach has two main limitations. First, the relevance and fulfillment of the measure are subjectively estimated. We risk missing the right measure. Then, the generation of the ideas of realization is not structured. It's in fact based on the intrinsic competence of business experts. To overcome the limitations of Ecodesign pilot's measures assessment approach, a new framework is proposed based on the use of TRIZ and ASIT tools. The next slides describe the main steps of this framework through its application to the Ecodesign pilot objective reduction packaging. The first step consists to analyze measures based on Ecodesign pilot descriptions, as well as the assessment question and the additional questions. As packaging material is useful only for a limited period of time, unless it's returnable, the type and quantity of material used for packaging have to be optimized, especially with products that have to be transported over long distances. The weight of the packaging material too has a great influence on the overall consumption of resources. Ecodesign pilot identified 5 measures to reduce packaging. Reduce material input for packaging, preferably use reusable packaging, preferably use renewable raw materials for packaging, preferably use recycled materials or packaging materials suitable for established recycling processes, and finally use environmentally acceptable packaging materials. The second step seeks to determine parameters of action and evaluation. The parameters of action are those on which we can act to improve the environmental impact as well as the functional quality of the packaging. The analysis of reduction packaging measures makes it possible to identify the following parameters of action: the shape of the packaging or morphology, the material type, reusable, recyclable, with little environmental impact, etc., and the thickness of the surface. The parameters of evaluation are those that estimate the environmental performance as well as the functional quality of the packaging. The analysis of reduction packaging measures makes it possible to identify the following parameters of evaluation: the resistance to shocks during transport, storage, and use, the quantity of substance for one use of the packaging. It's obtained by dividing the total quantity of substance by the number of uses of the packaging during its life cycle. The environmental impact is quantitatively calculated or qualitatively estimated according to the dioxide of carbon emissions and non-renewable energy perceived during the life cycle of the packaging, depending on the quantity of substance and the type of material. The third step consists to make some experiments. The experiments consist, first of all, to formulate the desired objective for the parameter of evaluation, and then to identify all the solutions available in the business and feasible in the context of the study for parameter of action. It can need an involvement of business expert. Finally, to test quantitatively or qualitatively all the possible combinations of parameters of action. This table shows the different combination of action parameters and use the possible ideas of realization depending on evaluation parameters objectives. The fourth step seeks to analyze the result of the experimentation. In the case that the experimentation table presents scenarios that make it possible to achieve the objectives set for the parameters of evaluation, the relevance and fulfillment for each scenario can be assessed using the same rating proposed by the classic approach of Ecodesign pilot. This assessment of each scenario, which is actually an idea of realization, is nevertheless more relevant because it will be carried out closely to a specific parameters of action as well as specific parameters of evaluation objectives. The estimation of the costs and the feasibility of the realization idea selected could be done similarly as the classical approach. In the case that the experimentation table does not present any scenario that makes it possible to achieve the objectives set for the parameters of evaluation, the relevance and the fulfillment lose their classical meaning of Ecodesign pilot and enforce the looking for creative ideas that are not obvious for business experts. In this case, TRIZ and ASIT tools are helpful and can be exploited to generate conceptual creative ideas of realization. Based on these conceptual creative ideas, technical solutions can be developed and assessed using the classical approach of Ecodesign pilot. The fifth step aims to generate conceptual realization ideas with TRIZ and ASIT tools. The analysis of the obstacles in relation to the objectives set for parameters of evaluation resistance and quantity of substance makes it possible to identify the technical contradiction between these parameters. It also makes it possible to highlight among the parameter of action, shape, material, and thickness, those which present a physical contradiction. The 40 inventive principles as well as the principles of separation in time and space could be used to develop innovative realization ideas. This is an example using the 40 inventive principles. According to the matrix of technical contradictions, the contradiction between the quantity of substance, factor to improve 26, and the resistance, factor that degrades 14, suggests the principles 14, 35, 34, and 10. For example, the principle 14, called spheroidability, suggests for packaging to replace rectilinear parts, surfaces, or forms with curvilinear ones, to move from flat surfaces to spherical ones, from parts shaped as a cube to ball-shaped structures. Conceptual ideas of realization could also be generated using ASIT tools. ASIT is a method of solving inventive problems resulting from TRIZ. It has 2 rules and 5 tools. Before applying ASIT tools to generate realization ideas, we need first to deploy the rule of the closed word. What is the undesirable phenomenon? The consumer throws away the packaging after use, thus producing waste. What are the objects of the problem? The consumer and the packaging. What are the objects of environment? The garbage can. What is the desired action? Prevent the consumer from throwing away the packaging. For example, the application of the unification tool of ASIT to the Ecodesign pilot's objective, reduction packaging, suggests the following conceptual realization ideas. The consumer will prevent the consumer from throwing away the packaging. The packaging will prevent the consumer from throwing away the packaging. And finally, the garbage can will prevent the consumer from throwing away the packaging. As conclusion, literature has shown the existence of several attempts to improve the effectiveness of Ecodesign methods using TRIZ tools. However, this paper presents Ecodesign pilot's first attempt to this focus. This work aimed first to study Ecodesign pilot, then to state a new framework for the ideation phase to fill the limits of this tool. As a result, 31 conceptual realization areas were developed using tools from TRIZ and ASIT for reduction packaging objective. Non-exhaustive research on the web has shown that some of these areas have already been implemented in the industrial context. The other ideas remain potential conceptual solutions for packaging reduction to be explored and translated into technical solutions by the designers. In light of these results and the exploratory approach conducted through the reduction packaging objective, several perspectives emerge. First of all, it's necessary to conduct a case study that aims reduction of packaging in a real industrial context based on the proposed framework. Then, it's also necessary to conduct other studies dealing with other improvement objectives and strategies to confirm the effectiveness of Ecodesign pilot new framework for the evaluation phase. It can finally be instructive to make a comparison between the Ecodesign methods that attempt to adapt the TRIZ tools to Ecodesign with our approach. Finally, this figure presents some conceptual realization ideas that have already been implemented in the industrial context. Thank you for your attention.